Last part of section 14.2 deals with wave behavior again. You need to state the law of reflection, describe refraction, and then what diffraction is. You can see your bell ringer explain the wave motion required to have constructive interference and to have destructive. I'll let you think about that. So 14.2 continued. A standing wave is the result of identical waves traveling in opposite directions. They're characterized by two parts, a node and an antinode. The node is the point on the standing wave where the medium is completely undisturbed. And the antinode is a point where maximum displacement of the medium occurs. So the node would end up giving form by destructive interference and the antinode by constructive interference. Standing waves kind of look like this. You have a wave like such and it hit a barrier and got reflected. It's going to reflect like this. All the places in red would be where your nodes are. Notice the wave is right at the same middle or rest position. The antinodes are where you have maximum displacement. So that would be where you have constructive interference between the forward wave and the reflected wave. Notice you've got 1, 2, 3, 4, 5, 6, 7 nodes and 6 segments of the wave. There's always one more node than a segment. The law of reflection says the angle of incidence equals angle of reflection. So this ray right here is considered your incident ray. The blue one over here would be your reflected ray. Angle of incidence, so by the way, the dotted line is called the normal. We've had that before, the line perpendicular to the surface. Your angle of incidence is actually defined as the angle between the incident ray and the normal. So this would be your angle of incidence. This over here would be your angle of reflection, and they will be equal. Now I understand that this angle here will also be equal to this one because you subtract 90, you get the same thing, but it's just not defined as that. So angle of incidence is defined between the normal and the incident ray. Refraction is a change in direction of waves at the boundary between two media. And these are caused by waves changing speeds. So if you go from one medium to another, the waves will change speeds and therefore bend if they entered at an angle. And I'll show you that here in a second. Diffraction is the spreading of waves around the edge of a barrier. And the smaller the wavelength, the less the diffraction. So if you have really long waves, they can bend more. So here's what we're talking about with refraction. Imagine I've got a boundary here, and this is air, This is water. This would be my normal. Here would be an angle or an incident ray. So there's my angle of incidence. Refraction says waves will bend at the boundary between two media. So instead of this wave continuing on straight like this, what actually happens is it bends like so, and this would be your angle of refraction. We'll talk more about this later, but you'll notice if you're going into a more dense medium, then it bends toward the normal. Conversely, if you go into a less dense medium, it would bend away from the normal. If you just reverse the direction of these waves, you went this way instead, now you're going from more to less, you'll notice it will bend away from the normal. I'm going to see if this actually still works real quick. So this is kind of showing you diffraction. You've got a hole here. Waves are coming towards that, and you can see that it's kind of bending around the corner and kind of making little semicircles and such. So that's what diffraction is. You can go to that website and play with different wavelengths and see how that affects it. The other thing to show you with diffraction, oops. If you have two holes or two openings, and I've got waves, each of these red lines represents a wave crest. So the difference between red lines would be a wavelength. When it gets to this opening, we know that it makes little semicircles. Okay, as in the video before. Well, this other hole down here will also cause it to make semicircles. And you'll notice there are places where the waves intersect. So right here, you've got the two crests running into each other, and right here, two crests running into each other. If you continue this pattern, we'll do one more here. There's another one right there. You'll notice right in between the middle of these two openings, there's going to be a place where there's constructive interference. Right here, here, and here, you've got another place where you've got constructive interference. Here, here, and here, a pattern of constructive interference. In between them, you've got a crest between two other crests. So that would be a pattern of destructive interference. And same thing here. In between these two, you'd have a place where there's destructive interference as well. So what you end up seeing are bands of, if this were light, whereas constructive interference, it would be bright light and then dark, bright light, dark, bright light, dark, and so on with your interference patterns. And that ends chapter 14.